press record on there. So hash tables, it's our week 4 of our data structures. Here's some info for, we're going to cover hash tables, which is, we're talking about the Java interface for hash table in this case, not the hash table itself, which is kind of the data structure that holds the information. So we're going to basically be talking about the interface that goes out and touches either pushing data out or retrieving the data. HashMap, which is very comparable to hash tables, and then HashSets. And then there's one practice exercise on here in LeetCode. Now there's probably about 250 actual problems in LeetCode that revolve around hash tables, but this is just an easy one just to kind of get you thinking about what the hash map looks like when you implement it. All right, so when do we use hash tables? You can either scream it out and put it in chat. Any guesses?
You want to hide the key value pairs names?
Okay. No, not so much hiding the values, but when I have a key value, a key and a value, then I can build a dictionary out of that. So I can use a hash table as a dictionary so that I can save that, so I can retrieve that information easy enough.
And you want low complexity with search, right?
To some extent, yeah. So when we use hash tables, at least when we're trying to solve problems, when we're trying to find duplicates in a series of either arrays or other data structures, whether it be lists or whatnot. So it's a good tool because the hash table and the hash set, both of them cannot have duplicate keys. So if you are using, or if you're trying to find duplicates in a list or an array, and you load that list or array into the hash table, you will be able to figure out what those duplicates are and then return them. Finding sums. So one of the problems that we're going to do here is we're going to try to implement a program where we are given an array and we are given an integer, and we're going to determine if there are two index values that their sum equals the integer. Sequences, again, so the hash set will not be ordered, but typically when you implement a hash table or a hash map, your keys are going to get ordered. So again, when you can sort, kind of a sorting type process, so you can find how those go. And then in real world usage, they're very often used for caching information. So old web pages, old images, comments, or whatever on your Facebook feed or Twitter feed, they're most likely going to get hashed and then pulled back. And I mean, really, the other real world example is anything Git. So although Git kind of works a little bit differently, but everything that you upload to Git basically gets hashed out into a hash table. All right, so we got 3 parts, a hash table. It's very similar to the hash map. They're almost exactly the same thing. But this is synchronized, which means, is everyone familiar with the Java threading?
I'm familiar with Python threading.
I'm not familiar with Python threading, but I'm imagining it's probably similar, maybe, my guess.
I think it's the same, just different syntax.
So,
But like running processes concurrently?
yeah. So with a hash table, those running processes are synchronized. In a hash map, they're not. So you're liable to get your unordered information back in a hash map versus a hash table when you're implementing them. It's really what it boils down to. They store key and value pairs in a hash table, not to be confused. So the interface hash table, not to be confused with the actual hash table where this information is stored. Yeah. So if you remember doing this in class, the big thing, and we'll talk about this in a little bit, is collisions, because you're basically setting your key, and then you're having some type of hashing technique to send your value to a particular index based on some mathematical formulation. I have pretty little pictures to show once we get to them, so you'll understand better. All right, so this is a example of implementing a hash table, both in Python and Java. Yes, I thought about you, Jesse. I want to go to master's program in Python. So the only thing that you're going to change here for Java is you'll just change this basically here, your interface commands to HashMap versus HashTable to implement a HashMap. And I think it's probably the same thing in Python, because there's not real difference in Java doing this except for the synchronization and non-synchronization. And to tell you the truth, the actual implementation of the hash table, that interface has been pretty much set to legacy by most programmers. Most programmers now much prefer the HashMap interface versus the hash table interface, because they get to kind of set up their own synchronization with the hash map, and they apparently appreciate being able to do that. I don't know. Anytime you have to type more code, I'm not too happy about that, but what do I know? I'm just a student. All right, so hash map, same basic concept as the hash table, but this one's not synchronized. And so the table allows you to have duplicate keys. This one does not. So that first piece of the essentially the 2D array is not, you can't have a duplicate of that, which when we are trying to solve certain problems, makes the hash map and the hash set more usable for us than a hash table. And hash map allows us to have a null key. Hash table cannot. And like I said before, it doesn't guarantee the order when you pull back the information, and it can change consistently because it is not synchronized. So this is what, because you're able to do more in terms of having duplicate keys and having null values, a lot of programmers would rather use this and just write up another method for synchronization to kind of be able to use this as a hash, quote unquote, hash table, and get your correct order back, because you get to have a little bit more meat and potatoes stuck to the bones with this than you do with the hash table. Okay, so we were talking about the hash table and the hash set. We were talking about key value pairs. So a key a value, and it's, you know, set up as a pair. So basically see something like this. 1, this is your key, comma, 0, here's your value. Love my, so you're gonna, this is what you're gonna see within the hash set. I mean, for your, when you return stuff from your hash table and your hash map. Hash set is somewhat different because with hash set, we are solely going to return one value. So all we're returning here is a key. So no values, just keys. Or you can think of it as values and not keys, either way. So, and that's, is anyone familiar with sets? Anyone know what a set is in Java or Python?
I never use it, so I forget.
You never use it?
I
Nope.
think I heard about this in algebra, but I forgot.
So a set works much like an array, except you cannot have duplicate values. So if you didn't want to find, if you wanted to make sure that you didn't have duplicate values, you could run your array through a set, and it would remove all the duplicates for you. Because this interface also implements the set interface, it doesn't allow duplicate values. So this right here is a key piece for hash sets when we kind of want to use them. So if we're trying to remove duplicates from a number of arrays or merge a number of arrays, typically we're probably going to use a hash set to do that because it will remove duplicates. All right. Now, of course, if we're merging a series of arrays and they want all the information to stay on there, we're probably going to find another method to do that. But that key piece, that no duplicate values, is key to when you start thinking about some of the problems that you may be asked to solve. All right. So this, just like the hash map, it's not synchronized, so it may come back in different orders. And null sets are allowed. So you could have a hash set that's null, which is a little bit different than a key and a null value. This is where all our values in the hash set are null. All right. So 3 pieces, 3 different ways to go back and touch actual hash tables. 2 separate words when I say that. So we have the hash set, the hash map, and the hash table. All right. So one of the things that happens behind the scenes in the hash table function, all right, that 2-word function, hash space table function, is we have our keys and we have our values, and that hash function then does that mathematical calculation to determine where the values go into the internal hash table. All right. And I should mess that up because that should be 2 words, but in other words, for example, we have well, let's change up a little bit. So the way this was set up, it was numbers, but I wanted to keep it with the program name, and I didn't realize that I should have changed the program, the to index, since the original one, instead the key was 9 and not John. So if, for example, we decided that, hey, we wanted to go by letters then instead, so our characters. So we could say, for example, that we go 4 divided by 6, and we end up with a remainder of 4. So this would have actually ended up, if we did it that way, that 99 would have ended up here. But
4 divided by 6?
yeah, modulated by 6.
That wouldn't have a remainder, would it?
Well, no, 4 divided by 6, remainder of 4. 0 goes in 0 times with a remainder of 4.
I thought that would, like 10 divided by 6 would have a remainder of 4. No?
Yeah. Well, 0 does too.
Okay.
Now, if it was 20, it'd only be 2. Because 0 divided by 6 is what? 0.
I don't know. I thought it was like undefinable or something.
Yeah, no.
Okay. Are you just trying to mess with me?
But so, but you would most likely just leave it as 4, because that would be the typical remainder. And that's fine the way that, this would work, because this would be 5 letters, so that would be, it's probably 5. This would be 4, and 6. There's already 6 there. So everything.
Are you talking about the order that you put the key in?
I'm talking about the order of where the value would go based on these
Okay.
mathematical equations by the hash function.
Gotcha.
Okay. So maybe it'll become more clear on the next one. So this is where we have collisions. Let me clear this out. All right. So we just have another set of arbitrary numbers. So we just say 3 here, 7 and 13 are our arbitrary. This was again 9, 7, and 13 before I messed it up and didn't follow my directions quite well. But here we have a collision because we have a 3. Sorry. We have 3 here. We have a 1 and a 1. So the first one will go to index number 3. But I have 2 that want to go into index number 2. So it's bad if you have a collision and you're not planning to have a collision. If you've planned to accept that you're going to have collisions and then have some type of means to stack those values into particular indexes and then be able to retrieve them based on the keys, then everything's fine. And that's kind of one of the challenges when you're designing a hash table, to ensure that those collisions are minimized, and if they do occur, then you are properly being able to retrieve the values based on the keys. Because right now, we know from the previous slide that Sandra got 100, and that Sammy got an 85. But if we go to retrieve that, how do we know who this is and who that is? Unless we've programmatically kind of decided which one's which. Does that make sense?
Yeah. So how do you prevent the collision?
You do more complex math.
Okay.
More complex math and more table space.
So you want to have some like gaps in between or something?
No, so you would have, so here we only have 3, but if we knew that a simple mathematical equation here was going to cause a collision, we'd make it different. We'd make the equation more complex, so that we want to keep getting, we want to be getting the same ones.
Gotcha. Use bigger numbers.
Yeah. And you could also do this is that when number 1 is filled, you can programmatically say that, all right, if number 1's filled, then we're going to start and fill this one up to the next one. We'll put it up here to number 2, and then we'll make sure that Sammy knows that its value is now in index number 2. Which poses its own problems, because if you have now an equation that gives you a 2 remainder, what do you do with that? I would love to tell you it's nice and simple, Clinton, but it's, I think.
What do they call it? Clustering?
What's that?
What do they call it? Clustering?
Yeah. Clusterings. Yeah. So we spent I think you spent like a whole week or maybe 2 weeks on this in programming 3.
And yeah, it's always half that during COVID.
Yeah. And I remember going through it and it was like, what the hell's going on? I definitely wasn't ready for that part.
So like who's going to have to figure this stuff out? Like if you're like in programming world, like why do you want to do this over just like a regular array and like a linked list or whatever?
So this basically is, you can think of this as a big dictionary. Yeah. Mm-hmm. Organization speed. Thank you, Ray. This cuts down, since you probably have not been exposed to the big O in terms of time complexity and space complexity.
No.
And those are 2 key things that you kind of start getting drilled in your head in programming 3.
Okay. That's probably why I never took programming 3. So.
And it is, you want to minimize the amount of time that you're, or effort really, that you're using the CPU for one, and then also minimize the amount of space you're using in the memory.
Yeah.
Arrays tend to take a lot of space because every index is typically a block.
Okay.
Yeah, like what Ray said, like you don't iterate through the data structure. You just go by the value. The value is converted to the index. So
right.
instead of searching through it like one by one, you just say, hey, Clinton, and then it responds back, I'm Clinton. And
Gotcha.
You only have to search with one process.
So you don't have to do like a nested for loop that searches by column and then row.
No,
It's extremely useful.
Yeah.
Okay.
So, for example, they use it in dictionaries. So, just as you would think, your key is Clinton, and like your value is particular, like your phone number. So, kind of like in Excel or Access, when you do your Control F, and I just look for Clinton, then I can find the value, his phone number right next to it.
Gotcha. I think I understand it now. I'm just curious though, like in your example, I know it's simple, but it's like, what problem are you trying to solve here? Like if your keys are John, Sandra, and Sammy.
So
you're just trying to make sure they go into the table without fail?
Well, yes.
Because like if you had a bad 2-index thing, like it would just fail or something when your program tried to compile.
Potentially we could have a failure with this, oops, trying to draw.
Would that be like a runtime execution error you'd get? Or would it be
no, that would be a compiler failure.
Oh, okay.
So here or runtime failure or whatever you would call it.
Yeah,
Because-
exception, I think.
Yeah. Because that would be it. Because this is would try to be getting into this index here, and it's already filled. So without knowing what we should do with this, it's going to fail because it's already full,
Okay.
and the whole program's going to crash, and everyone's going to be unhappy.
And like in an example, would a program try to set up a hash table whenever, say, you would import like a CSV file or some sort of data, and make it
Well,
faster?
I mean, I mean, it's not going to do that automatically. The programmer is going to have to build that.
That's
out.
what I'm saying. So
Yeah.
like you would have to learn how to do this if you wanted to have that sort of like importation feature.
Yeah.
Okay.
Oh, I have a good example. You know how there's high scores in video games?
Mm-hmm.
Like
There's
you could
tons,
put it
right?
in a search. You could put it like a little search form and
Mhm.
just look up the player name, and then you can use a hash table to find the experience.
So it'd be the name and the score.
Yeah, instead of actually like searching through the whole high scores, like where is this guy?
Gotcha. All right, that makes sense. Sorry for the noob questions. I was just
No, that's
like
all right.
trying
why
to
we're
catch
here.
up. All right.
Well, apparently that was not mine. I heard someone's Discord beep. I thought it was mine. Someone else is likable, but not me.
Yeah, I don't know who that was.
All right. Oh, my match is all messed up here. To remember that. All right. So Clinton, this is something that we've been working with for a couple of weeks. This is our, man, it's all messed up. I had a lot of problems. Working with PDF is not easy.
Do you have the full version of Acrobat or what?
Yeah.
Oh, okay, nice.
Scratch all these out to come back later and update all this. But needless to say that every time that I would save, it was not liking the it's like that Geico commercial where it says disco snouts. So this is our 7-step process that we're using to solve any problem. Kind of our critical thinking framework. So the first step is to understand the question. So when you have the problem set in front of you, do you understand what the input what the input is to get the expected output, and vice versa. Do you know if the information is always going to be given to you this way? Is it going to have small letters if you only need capital letters, that kind of thing? Basically, just understanding exactly what you're doing before you start doing anything. And a lot of people preach to read the problem like 3 or 4 times so that you truly understand what it is it's asking of you before you even start doing any work in coding or anything else. The second part is matching. So today's going to be kind of easy because we're kind of matching to a HashTable or HashSet or a HashMap. Not too complex, but when you get to problems that are either given to you in class or you kind of got you built out yourself in your own project. I don't know how long Selena's been here, but hi, Selena. Well, the match part is matching that to one of the known ways to solve this problem that you've used before. Right. So if you've had like a like problem like this before, and you use, for example, a linked list to solve it before, then you may want to try using a linked list to solve it this way. All right, and we'll talk a little bit more when we get into the actual process. Then writing your pseudocode or comments, or just planning out what you're going to start typing in code before you start typing in code. Trying to ensure that before you just start going to town with that code, you're trying to keep it as clean as possible. I know that when I first started, and especially even in the programming 3 and algorithms, I'd be writing lines of code that I didn't even need, and just kind of wasting time trying to figure out how things were going. But if you kind of think about just those certain parts that problem is asking about before you start putting fingers to the keyboard and in the IDE, when we get to the implement step, then you'll be much better off. All right, so going to the implement step is just writing out the code. By this time, let's say you're given an hour or so to get to a particular problem, you're probably wanting to just only spend like 10 minutes, actually typing out the code, because by then everything should be pretty much hammered out in your mind. The pseudocode's already done. You know that you're going to do a loop here. You know that this variable has to come through and change values here, here, and here, and then it'll return, this particular value. Review. So this is where we want to start putting in some test cases, and especially want to use some edge cases. So if, for example, we're, I think programming 1 just did a project trying to put names in alphabetical order. I think it's like the first or second project. So they're taking the first character off of the name and then comparing it to one another. Well, it works perfectly well when you have a capital A and a capital B. But if you have a small a and a capital B, guess which one comes first in the program? Everyone want to guess?
Capital A?
Well, capital A, but if it's a small a and a capital B comes first. So already you're not in alphabetical order. So how do you mitigate that problem? Well, the way that I worked around it was I didn't match it to themselves. I matched it to small z, which is the 52nd character, and then did my math and compared everything to the small v or small z, and then said, all right, if I'm if I'm the largest number, then and then what I do, and then I match everything to small z, and then I did a if statement for anything under 26 and under, and then I added 26 to it, or something like that, just so that I could get all the edge cases in. So because it was all entering information, so it wasn't just taking it off of an already preset format. It was actually user input. So if someone messes up one thing, and then everything's totally off. So just one example of an edge case that you might have to worry about. Or what if you're expecting null values? So if you're expecting null values, for example, and you're thinking a HashTable or a HashMap, which one are you going to use and why? I'm going to say HashMap because HashMap accepts null values and HashTable does not. And then evaluate. And that evaluation is just going in and checking your big O components, whether it's a constant, linear, exponential, polynomial, logarithmic, whatever it be, as well as your time. You can kind of think about that when you're up in your planning stage. So up here, actually anywhere in matching, I would say you can kind of think of your big O's there,
That makes sense.
because one of the things that you're going to want to do is you're probably going to want to have more than one way to solve the equation, especially if it gets into a point where you can't work the edge cases through one particular way.
Yeah. I wrote a web server, Leo, and the first time I did it, I evaluated it and it was terrible. And then I was trying to figure out how to get better. So I don't know. I studied and then I did it again way better. But what do you do when you want to get better? You know?
Yeah, I gotcha. More practice,
I guess so.
more YouTube.
More Udemy.
Yeah, whichever way you want to go. If you want to pay, that's fine. All right. So here's our first test case. All right. Jesse, could you set up a Repellent page for everyone to link to?
I try.
You know how to do that in Java?
Oh yeah, of course, in Java. In Java.
You guys use Eclipse?
I've been using IntelliJ, but
It's in the chat.
we're going to be using a an online version. Am I sharing this?
Did you were you able to get in?
Mm-hmm.
I don't see anybody on the.
I have a feeling you didn't. Can you click the little share in the upper right
Oh, okay. I'll try this
and
one.
post that link? Yeah.
Okay, I see you.
Okay. I see you. Your arms crossed.
Yeah, that's the only picture I got.
All right, so I'm going to do this.
Okay. Given an array.
All right, so we have our problem here. I'm going to get rid of this now. So we have an array of integers. All right. We're going to return indices of two numbers such that they add up to a specific target. All right. All right, exactly one solution, and we can't use the same element twice. Makes sense. So as an example, we have this array here. Our target is here. Anyone have any questions? Any other, any edge cases or any other examples that they want to put in as test cases?
We could do 18. 7 plus 11. Or I guess I'll write it, yeah. Jesse.
You got one, Ray Crit? And give us a return value too, Jesse, in the next line.
I'm interested how to do this in Java a little bit. Oh, man.
Change this. I changed your return numbers, Jesse, in a way.
Why?
Because it's the index.
What the heck? I'm curious. Oh, well, whatever.
So it's just the indexes. So 1 plus 11, 0 index, 5 index.
Oh, okay. I must have put the numbers, I guess.
You did 1 and 11, that's all. See, understanding what we're supposed to return.
There you go. Array and
What do I return? In line 17, what should I expect to return?
what? There's no.
Oh, yes, there is none, is there?
Oh, okay. I thought I was dumb from it. No, that's all messed up.
So the question is, what should we return when we don't have an answer?
Oh, I would say either an
It's gonna be
exception
0
or
and 1, Ray. You return. Oh, okay. Now it's 0 and 3.
0, 1.
Oh, actually, you're 4.
Is it possible to run separate main Java files on their own in the same repellent?
No,
Darn. Okay.
let's not get ahead of ourselves. Yeah, index positions. So what if we just do null?
I like that.
Does that work?
That works. Oh, we're doing umpire. Okay, I finally caught on.
Just like last week?
Yeah.
The week before?
My bad.
All right, so with comments, how are we going to start running through this program? Down here in line 26 on.
I'd say find out what numbers add up to 9 and then test those against the hash. So we use something to find out all the numbers that add to 9 first.
Okay. How do we go about that?
We could make 2 arrays and make them add up to each other, going through every possibility to 9, but that sounds very wrong. I don't know.
I have a question. Hello?
You're quiet, but we can kind of hear you, Ray.
Oh. Hello?
Better.
Okay. So is this the hash? Is this already in the hash table, or is this what we can put in the hash table?
This is what we can put in a hash table.
Okay, I was thinking, what if, because the hash table organizes it, so what, I don't know what I'm trying to say. Well, because what I was thinking was more of like an array. So like if we put every number, because since we're only using numbers, if we put them in like a hash to where that key is just that number, since we're only using numbers, then we could, never mind. I don't know what I'm thinking.
All right, well, let's since we have a little confusion here, let's make sure we get our M right, our matching. What should we be using here? So what are our arrays? What's inside of our arrays?
The numbers.
What's that?
The numbers that we need to add.
Which are called what? That starts with a V and ends with a U's and has an L in the middle. Values.
Oh,
Oh, I thought you said B, not V.
Oh.
I was like, blues?
Oh, do I gotta do a Spanish thing? B is in burro and
B for big.
B is in vaca. So we have values. So if we're going to use a hash construction, which one only uses values, since we do not seem to have the other half? What's the other half of the hash table? Values and
The key.
oh, keys.
Yeah, do we have keys?
Well, we could create keys. Couldn't we?
I guess technically you could. You could pretty much do anything you wanted, but
it's not what we should be doing.
Shouldn't the
not
key be the
not the
value?
optimum method. So if I took my array and I put it in a hash, 3 chances, 33% chance you're right. Hash, and that second part has 3 letters.
Both have.
I assume you're talking about the set.
I
Yes.
want to go with map. Darn, I was wrong. Okay.
Why would we use a set versus a map or a table?
No duplicates.
because we don't have any keys. So the hash set
Oh.
has values,
Oh, I don't know. Okay.
and our array has values and no keys. That's why.
Oh.
Make sense?
Yeah.
Kind of.
Yeah.
Tracking on that, Jesse?
Yeah, I'm Googling.
And you can solve this one of two ways, I think, easily. One is iterative, and one is with the hash sets.
But would hash sets be faster? Probably, right?
Well, if we're going to, well, let's go to, what is it? Actually, I just go up here. Oh, I have it bookmarked. So hash, where's my hashes? Oh, of course, hashes aren't on here, bastards. Let's just say, I believe, looking into a hash at and inserting and removing is O1, big O1 constant. You can Google that and tell me if I'm right or wrong, but versus your iterative means, and I believe if we had to do it iteratively, we'd be exponential because I think we'd have to have nested for loops at a minimum to compare. Does that make sense? Yeah. 2 for loops to compare to each other. We did that a couple of times in algorithms, accidentally, I guess, or purposefully, I can't remember. And I think we just go, this is, no, some string. Oh, this is different. Minimum sum, compares, minimum sum. I don't know where it is. It's somewhere in there. But either way, if you find it on Geeks for Geeks, it'll probably give you both ways, both iterative and through the hash set. I think if you just Google, actually, this might be easier. Hey, look at that. I think it's the same thing, huh? So yeah, brute force, your 2 iterative, you get O(n) squared, and then your hash. So, oh, these guys are using a map, but
Yeah, the one I mentioned with brute force, I guess.
yeah. So we're matching up. This is going to be ON, ON squared. You're still only using an array, so it's just going to be a constant, I think. Yeah. Oh, so yeah, I think they're doing a hash map and they're putting in, what are they putting in? ON. I'm using one here as,
Do you know what ON means?
yes. So ON is a constant, well, it's not constant, it's a linear time. So this is your complexity chart starting with 0 down here in your, oops, sorry. I meant to annotate and I wasn't on annotate.
So you want it to be yellow or better or lower?
Yeah, so this is your power for your CPU. That's how much more power you need. So, and this is the number of basically it's like the number of, I want to make sure I say this right. It's like the number of
CPU cycles?
no, it's like the number of, like if you had a variable, for example, that was like 9 and it ran at 0.1 at constant speed, it would basically be at 9 all the way across. If that makes sense. So if it's ON typically is something else combined with a constant. So it could be two different variables added together. So that line gradually moves away from the 0 plane.
Can I see if I understand this right? So like O of n, if I were to run a function twice that was O of n, it would be like 2n or what?
Yes, but it still gets simplified down to n.
Okay.
But if you were, for example, a for loop is an n, is O of n.
For how long the for loop is, right? N is the length of the for loop.
Yes. Now, if I put a for loop inside of that for loop, now I get to the squared.
Because it's the length of the inner for loop multiplied by the length of the outer for loop, right?
Yes, which is n times n. If I have a for loop, I end that for loop and I have another for loop, then it's just n plus n, which is 2n,
Right.
and we just drop the 2.
And we're just counting the number of operations total.
Well, that would be, yeah, when she goes and counts the number of operations in programming 3 or in algorithms, yes, that's how. But 2n or 3n is still n. It doesn't matter if you have, you know, well, I mean, I guess it matters if you have like a million n, but if you have n to the millionth, then it's totally different, right?
Yeah, my website, the one I mentioned, was wasting like $3 a day on my Google Cloud, and I couldn't figure out why. And then I took programming 3.
Yeah. So typically, Clinton, we want to stay in, you know, the in a perfect world, we want to stay in the green, right? You know, it's like your RPMs on your car. Oh, excuse me.
I get it. It's like orders of magnitude, kind of.
Yeah. Because the you know, and this will happen if you're, you know, stressing out your CPU and it goes and asks for the GPU to help out, and all of a sudden that GPU starts whining, that fan goes, "Wah!" and it's running like crazy. You're like, what the hell did I just do? Yeah, that's when you're starting to get up into that exponential range, and you'd be surprised how much exponential stuff is out there. And you can get away with a lot of exponential stuff if you're dealing with small numbers. I mean, down here, down in this area, it's not too bad. But when you start, hey, I get like 10,000 lines I'm trying to go through, and then all of a sudden I'm getting crazy on how long it's going to take all those calculations to be done. So for example, are you familiar with recursion?
A little bit.
So basically, the program calling itself basically in a loop until it solves the problem.
Yes.
So there are a couple problems in programming 3 that we ran. I think one of them was called non-tail. Is that correct? Tell me if I'm right, Ray and Jesse. Like non-tail was one.
Oh, there's one about a tower. I don't know.
The
There was
Hanoi,
like three.
the Hanoi Tower. Non-tail, which goes out 1, 2, 1, and then it goes
Oh yeah, I remember that.
1, 3.
I still don't understand that one.
So there's all these kind of computer generated, not computer generated, but programmer generated problems that if you could type in 9, like just the number 9 into this program that is only like 5 lines of code, and it could run for like 5 or 6 minutes to get you the result. And like the non-tail and the Hanoi Tower program are 2 classic examples of that. And Hanoi Tower is you have 3 towers or 3 sticks, and then on each stick you have, or on one stick, is it one stick? Yeah, you have one stick that has 3 rings, a large one, which is on the bottom, a medium one, which is in the middle, and a small one, which is on top. And they always have to stay in order. And how do you get it to, how do you get it to the other side, to the 3rd stick in order? So you have to move the first one off to 1. You take the second one off, stick it on another one. Well, how do I get the last one off? Well, now I got to take the small one and put it on the last pole where the 3rd one was. Well, that doesn't help me now because now the bottom one has to go in the middle, and now I'm kind of screwed because I still have to move it over. So if I put the small one all the way to the 3rd one and put the middle size on the middle pole, and I put the small one back in the middle pole on top of the middle size ring, take the big ring, put it on the 3rd pole, take the little ring, put it on the 1st pole again, put the middle one on, put it on the 3rd pole, and then take the first one and put it on the last stick. So now I have my towers back on the 3rd stick, and say I want to have 6 or 7 iterations of that. Computing power, freaking, it sucks the life out of you, or at least out of your laptop. There's just so many mathematical calculations it has to do.
Thank you.
All right, and so this is for CPU. It's the same thing with space, but typically we don't get to anywhere close to the red. Typically we're just dealing with stuff in the yellow. We're usually somewhere in O1 or ON range for space. Typically get, unless you're doing something really bad, getting outside of the ON realm. Can you guys think of?
I did.
What's that?
I did something in the red, and I just went through my money.
Yeah. So, all right, there's 2 worst cases: quick sort could be a login, and skip list could be a login for space. But again, that's only getting up here, so it's not getting crazy off the charts. All right. So we're going to we'll go with what Rico kind of said there. So we'll let's try to do it with a map. So then we're going to, how are we, what are we going to do with a hash map? How are we going to fill it with our array information? Any thoughts? Since we'll use a key and a value, but we're using them a little bit differently than just a key and a value. What do you think, Ray? You guys still there?
I'm here.
I don't know the functions of the data structure, the methods, I mean.
So we're gonna have to iterate our information in first, right? Does that make sense? Use a for loop, for example. Which means we're gonna have to so if we think about it this way, what if we, it won't be capacity. It's going to be integers, and there's the angle brackets to implement, not parentheses there. What if we use the known integer as one of the keys or the values? Do you know what I'm saying? Oops. I don't know what to do. Why am I not being able to go over there? So if we do something like, we fill it with I, and then with K. Or vice versa. There we go. All right. Having issues. Can you guys hear me? Please
I
tell
do.
me. Okay. I can hear you. All right. I don't know if I locked up or something happened. All right. So if we do like the array values and then K, maybe we change that from the other way around or keep it that way. I don't know. But then what we can do then is maybe find the other value by K. Something like that.
The one on the right key, that's index, right?
Well, in here, that's going to be
The value, yeah, each element.
this is your key. This is your value. So if you subtract the key from the value, you know that you're looking for this number. So the other value is the number we're then going to find in the hash map. So we do that calculation because now if we keep this as the key, it's easier to find the key than it is to find the value, right?
That is so cool, yeah.
So then here we go, like
Value minus key.
probably gonna have to find the indices there too. Other one, we're probably gonna have to have some. Can we implement this? Maybe. Want to try hammering out some code, Ray? You can join in the fun too, everyone else. So up here in line 32, Ray, what's the first thing we need? Or is it going to be void? What do we have to return? I think for the sake of simplicity, it'd be ints. Maybe, I'm not sure. We'll figure it out. I think it's at least going to be an integer. All right. Hey, Jesse, can you build the main? You can just build everything underneath the comments. That way.
Okay.
Well, no, like you go here.
Oh, okay. I do my best, but I don't. Okay, anyway.
Yeah, AR is fine. And you can fill it with one of the test cases.
I guess that's pseudocode for today.
If I want. Well, we have a, yeah.
Quality assurance.
I mean, you could do that, or you could just do the print statement right there if you want. I think you only really have to do this. I think that will suffice.
1, 2, 3, 4. Okay.
Because I think if you do it that way, it's going to want the size.
Gotcha. That makes sense.
Because these are just integers, do we really, what if the key is just the integer? Or no?
Like that?
Like this.
No.
No. Okay.
Why not?
I don't know.
Because when it comes time to search for the value of the array, which is here, it's going to be the key, and it's going to be easier to find than trying to find it in the value. Does it make sense?
No.
So let's say I'm looking for Clinton. This is where Clinton would be. His phone number would be K. If we switch that, now I have to know what Clinton's phone number is to find Clinton. Does that make sense?
Yes.
Okay.
I have no idea what's going on.
Are you okay with code intelligence, Leo?
What?
Are you okay if I turn on code intelligence to see if it works?
Oh, sure. I mean, I haven't used it before, so.
Okay, try it. And let's see if that'll help.
It's like auto complete.
Well, it's supposed to show the methods if you scroll over the type.
Oh, okay.
And that would be useful. So if you put your mouse over any data type now, you'll see some documentation, but I don't know if it's helpful at all.
Okay. I don't see any documentation, but I guess it's just turned on for you.
Oh, okay. That makes sense.
I don't think this, I think this second number is supposed to be I, right?
Okay.
Are we gonna make our own hash? Because originally it was K, but that would be wrong because the target is 9 and we're inputting the target as K, which would mean that it'd be putting it in the same place over and over again.
Okay, that's fine.
Because I don't know what kind of, what hash we would use if you wanted to do like a really,
Oh, you know what? I know why we're gonna do that. You know why?
no.
So what does this return this way?
What does that
what kind of vital information or did we miss if we didn't have that second I?
The location, the index
Exactly.
of the
We need
hash.
to return that. So
Well, because that's what I was, no, never mind.
no, I agree with you. So I don't know what you're talking about.
Well, no, originally I was thinking for some bizarre reason that it needed to be ordered. So I thought that if the key was going to be the same as the value, I thought that would be easier. But then I did realize I had no idea what I was trying to do. So then that was probably not the best thing to do.
Oh, makes perfect sense what you're doing.
But it also makes me wonder why we need a hash in the first place if we're just ordering it by an array. If we should have just used an array.
Well, you could, but why didn't we use an array?
I have no idea.
Brute force, right? We're trying to avoid that.
Because it was n squared.
Right.
But isn't this still going to be n squared?
No.
If we're doing the same method? No?
No, it's not the same method. Using that, you're putting in a hash, which right now is what? ON.
But then how are we supposed to retrieve that information?
then that comes out as another ON.
Because in the example that you were writing on, the example that you sort of described here is the value minus the key. So what I imagined was happening was the value minus the key. Hold on, never mind. Hold on.
Well, that was before when we had K. That would be, this is K.
Well, that makes even less sense.
Why?
Because that K is just a letter. I don't know what K means. What is K?
It's 9 in this case. 9 minus the first is 2, right? 9 minus 2.
Oh, okay, that's right.
Oh,
All right.
that.
All right, 9 minus,
And then we have a number 7, yes?
Yes.
So if we find the number 7,
And how are we going to find that number 7? We're going to iterate every single hash.
no, we don't have to iterate every hash because there's a key.
But how does that 7? But the key's not made.
Yes, it is. You made it here in 42.
But if the key is 7, what's in 7? It's not going to be 7.
No, it's 1. Why is it 1?
I have no idea.
Because that's index 1. And 2 is 0. In 11, there's 2. In 15, there's 3.
I have no idea.
You built the loop right here.
Well, yes, but that 7 is supposed to be the key, right? What is 7?
Yes, the key is right here. Array.
The key is 7. So at index, so if the key is 7, there is no key 7 in, because there's only 4 numbers in the array.
What are you talking about? Key 7. You search for 7.
But that's the value. That's not the key.
Yes, it is the key. The value is 2 or 1. Sorry. First part of your.
The value, I thought the key was going to be I thought the key was the index, right? Of the hash table, of the hash map.
No. The key is, in this case, get my draw here. Let me get my draw on. This is your key. This is your value. Key value pair.
Why is why is the value not the actual number that's in the array? That's what?
Because, like I just said, with the previous example, if, for example, our key is Clinton and our value is his phone number, we search Clinton and we find his phone number. If I switch that around and now his phone number is the key, I have to know Clinton's phone number to find Clinton. Here, in this example, we're pulling out the values of the index, of the array, but we're also saving the index. So
it'd be 2, 0, right? 2, 0?
Yes.
Okay, good. Got that far?
So you get 2, 0, you get 7, 1, you get 11, 2, and 15, 3. So after you've then done your math here, where you've taken your K, which in this case is 9, all right, and we're going to most likely have to do another loop here to iterate through each of them. Probably a while loop or something. But in any case, we find 2 and we subtract 2 from 9, and that answer is 7. So now we look into the hash map for 7, and we find it here. If these were the other way around,
Yeah, now it doesn't make sense.
I
Okay.
can't find 7 because I'd have to know that it was at index 1. But now I know that 7, which is 9 minus 2, is at index 1. And I already know that 2 is at index 0. So I've now solved the problem, and I can return those two integers of 0 and 1, 0, 1, sorry. 0 and 1. Does that answer the question, Ray? Are you understanding better?
Yeah.
It's not very confident. So you could do this offhand. Is there a size helper in HashMap? I.e. length?
Oh, cool. Yes, there is. There it is. Size. Try that.
Okay.
You should try the code intelligence or whatever it's called. Intelligence. It's pretty cool. It actually showed all the methods.
Oh, did it?
Yeah, it was awesome.
No, it's just like my my IDE. For real.
Because I don't memorize any of the methods. I just use IntelliSense.
So I think if you need to do that math calculation, but the best way to do that would be
Okay, so K.
so you could either put it in another giant for loop or a while loop, however you want to do it. Or your for, I think, would be something like never get that right.
Hope that works.
So then we take Sum equals, okay, minus,
Hash.get maybe? I don't know.
no, it's hash dot get.
And then with the object key and the argument. Where'd it go? There it is. Ooh, and it shows you the return type. That is so cool.
Oh, so it's not, okay. Can I do it by value?
Oh, I see what you mean. I don't know. Just by value. How do you tell this by value or by reference?
Or actually, we could just probably,
Well, mine just exploded.
yeah, well, you just exploded everyone's, I think. I don't think it's, yeah.
My Wi-Fi is working, so.
No, everything, they just, the entire thing crashed. There we go. Because we don't want that, we need the value, because that's going to send back the, I mean, that's going to, we're looking for value with I, so we need to find the key. All right, I'm going to go cheat.
Oh, solutions. Great. Is that a length? Dot length?
Oh, that's, okay. So they use the array to do it. And then they went and they did the if statement here. If contains, we'll be cheating here, but we're running out of time. Key.
Time complexity just got too big.
Sum. Get. Sum. Equal to 0. Right one? No, I didn't equal to I. Then we will return.
I gotta go. Talk to you guys later. Thanks for the.
Okay,
workshop.
Clinton.
I'll try to make it to Wednesdays as well.
Yeah, we're gonna do some web forms and stuff like that.
Sounds good.
Take
care, everybody.
From a new class.
See you then.
Get.
Yeah, I don't want to exit out because then it might shut everything down on your side.
Some. And then we end up with, okay, and we have a throw. Just gonna copy this one. This is outside the for loop, I think, right? Yeah. Ooh. See if Jesse did everything right. Okay. Right. Oh. Thank you, Ray. Oh. Map.
Must have said put the function name wrong in the main.
Oh, do we? Oh, yeah.
Try that.
We're still having a problem with the map. Arrow map. Okay. Oh, I know what we did. Oh.
We got a memory address, isn't that nice? So I think we need to return something in general.
Hash.
Oh, maybe we have to turn it into a string. I don't know if print does that automatically.
Oh, it should. But it still came out as a memory.
Does it exit outside of the throw or the return?
So if, for example, we did 10,
Okay, there's one exit.
yeah. No two-sum solution. All right. And then let the yeah, it's
Oh.
so we're returning a I.
I don't know if returns are reference or value.
Oh no, because I think it's because it's returning an array. I think that's our problem. So here, so much here. But it's taking in, should be taking an array perfectly, hopefully. Stupid Java. Print. See if that gives us what we're looking for. Not so much.
What if you do like this and you return
Oh,
it,
you know,
and then it's not length, it's like 2 because there's only 2.
no, I don't think it's going to do it.
Oh, making me think of Python memory. Oh,
Yeah.
I can't even.
Yeah, see, now I get 2 memories.
But
I think
maybe you could assign it, right? Assign it to a variable and then just.
yeah, that's what I was just thinking.
Do exactly what Ray was saying, but with an assignment. Yeah. And then the little I. What do you call them? Index. Yeah.
Index. There we go.
Bam. Did it win? Did we win?
12.
Oh, sorry.
Or is it oof? I don't know.
No, I'm not messing. I'm just bugging him.
There you go.
Heyo. 1, 2. That sounds correct. 7 and 11. I can add.
Yeah.
I
because
can't.
it changed, so thank you for reminding me I changed it. So if I get the original, I should get 0 and 1. Yeah.
You passed the interview as a group. We all get the job.
All right. And we only had to cheat a little bit.
Spectacular.
All right. That's how it works.
I don't think we can cheat on the.
I got index cards. I'm going to bring them to the interview.
All right. So I'm going to go back over.
Wear some really big glasses and tape the answers on the top.
All right. So if you guys have a chance, there is another problem on here. It's the joules and stone problem. Basically, your joules, if you have a small a or a capital A in this case, it's going to find supposedly the small a's and the capital B's. And that should probably be 3, but because all my shit's like double up at places because of my font issues and erasing stuff, I can't even describe how it worked. I would type, I go to the next page, and I look back at the other page, and like half of all my characters were gone.
We could put it in the repellent, this, and then we'll like figure it out.
Yeah, but that should be.
I don't know if you guys
It
even
should
got
just
the
be
text.
3
3, okay.
versus 1, 2, 3. Z here, there's 0, so like that shouldn't be there.
Oh, okay. So how many times does A and capital A appear in S, right?
Right. And how many? So your joules and your stones.
Okay.
Your joule, your lowercase z. How many stones contain are lowercase z in this case? 0.
Yeah.
So ZZ top, as we all know, is capitalized. So
I've got some ideas.
all right. So we're a little after 9, so we'll end it here. So at your leisure. And I will just, for example, do a little search on the interwebs for, oops, I don't have a mouse. Code. So here are all of the particular hash table problems. I've only done like 3 or 4.
Out of like what, 150 you said?
Yeah, well, out of all those, there's quite a few. I've done all the easy ones. So intersection of 2 arrays, easy. Happy numbers, easy. 2 sums. Longest string without repeating characters, I've done that one. I haven't done the joules one yet. This is, so you can actually do it on leak code, and you can start putting a leak code portfolio together. There it is. Problem 771, jewels and stones. It's even easy. 86.2 of people have solved it. All right. You guys have any questions?
Oh, just one. What is the collections mean when it comes to Java and stuff?
What do you mean collections?
Oh, okay. Like, I don't know. I was just told that there are advanced objects and in the collections, and I just saw that in multiple languages that they kind of group together all these objects in a library called collections.
Oh, okay.
Yeah. Yeah, I was just asking about that. I'll Google it.
Yeah, is that like utility as a collection?
Yeah, I never heard of it until maybe 2 weeks ago, and I was just wondering. Yeah, sorry about that.
Yeah, well, I've just heard thanks for sharpshooting me on camera.
Sharpshooting, what's that mean? Oh, man. I haven't heard that one before. You sharpshooted me.
Yeah, you're asking me questions that you know I can't answer.
Oh, no. That was not the intention.
So
Okay.
please feel free to do some extra problems. It's only going to help you. It's not going to help me. So, and Wednesday, if you want to come, we're doing HTML forms and some more Bootstrap, and it's probably going to be geared a little bit more to the new web class going on. So,
Cool.
but if you haven't done haven't done forms before, then feel free to come in and get some practice.
Are you gonna do repeats?
Maybe.
Yeah, because you could probably recycle your previous workshops. They do it on Meetup a lot, where every like other month they'll do some other workshop.
Yeah, I'm going to stop recording. So.